Let us now talk about advantages and disadvantages of a circular linked list. So the first advantage is we can traverse through the whole list from any node. So if I give you reference to this node, right, in a variable r, and if I ask you to traverse through the whole circular linked list, you can easily traverse by running a loop. You will first traverse 20, then you will go to 15, and using next you can come to 10, using next you can come to 5, and you will stop when you come to r again, right? So this way, from any node you can traverse the whole list, whether it is 5, whether it is 15 or 5. You can simply begin from that node and you will stop when you come back to that node. So that's the first advantage. Next advantage is implementation of algorithms like round robin. Round robin is a CPU scheduling algorithm that we generally study in operating systems. So in this algorithm, we traverse through all the processes. We maintain a queue of the processes. We traverse through this queue in a circular manner, and CPU is allocated to these processes one by one. And when a process finishes its execution, it has to be removed from the circular queue. So we need to have delete operation. We need to traverse them in circular manner, and we want to update their time slots also. All these operations can be done very efficiently with a circular linked list. So this is one classic example or application of a circular linked list. Let us now talk about third advantage, which is we can insert at the beginning and end by just maintaining one reference or pointer. See, if I see the circular linked list, this is interesting and can be useful for implementation of queue data structure. If I just maintain tail, right, and if I ask you to insert at the beginning, what you will do, you will insert a node after it, right? You just need to change the next of it and next of the new node, and you will be able to insert after it. And if it is insertion at the tail, then you will update the tail pointer or reference, and if it is insertion at the beginning, then you will not update tail. So in both the operations, you will just insert a node between 15 and 10, which is possible because it has to be next of 15. And when you are inserting at the beginning, you will not update the tail. When you are inserting at the end, you will update the tail. So you can do both operations in big O of one time by just maintaining one tail variable. What happens in singly linked list, say you have this tail here, right? And if I ask you to insert at the beginning and end, it's not possible, right? By just maintaining one variable, I have to maintain two variables, head and tail, right? That's the only way to allow insertion at the end and at the beginning in big O of one time. And with this setup, we can also delete from the beginning in big O of one time, right? We can do all these three operations: delete from the beginning, insert at the end, insert at the beginning. So delete from the beginning is also easy. I just need to delete the next of tail, right? And I don't want to update the tail because it's a beginning node that we are deleting, right? So this is also possible in big O of one time. In singly linked list, we can do delete from the beginning in big O of one time. In fact, we can do all these three operations in big O of one time. Delete from the beginning, insert from the beginning are possible in big O of one time by just maintaining head. But insertion at the end is not possible with just one variable. We need to maintain one more variable. And it's possible with one variable in a circular linked list. Let's now see how is it useful in implementation of queue. See, in queue data structure, you delete from the front, right? When we'll study queue data structure, we'll see we delete from the front and we insert at the rear or the last position, right? And deletion from the front is possible by just maintaining one variable, and insertion at the end is also possible by just maintaining one variable in circular linked list. Let's now quickly talk about disadvantages of circular linked list. Since we need to make it circular every time, we need to maintain it as circular, operations like insert, delete, search, they all become slightly complex. In fact, traversal loop also becomes slightly complex. We are soon going to discuss these operations, and you will see writing code for those operations is slightly complex when you are maintaining a circular linked list compared to a normal singly linked list.